welcome to the Tech Life Well podcast. We're delighted to have you with us,
where we make technology simple, thoughtful, and useful. For more insights and episodes, visit techlifewell.com.
Welcome to the Tech Life Well podcast, hosted by Theo Hale and Aria Wells.
It's great to be here.
So if you were anywhere near, a glowing screen on February 5th, 2026, you probably felt the ground shake a little.
A little. I mean, metaphorically, sure. But in the tech world, it felt like a 9.0 on the Richter scale. It was one of those days you just stop working and stare at the feed.
We're talking about what's being called the February collision. Two absolute giants, OpenAI and Anthropic, basically decided to wake up and just choose chaos.
Within the same hour.
Yeah.
They both dropped their flagship coding models. You've got GPT-5.3-Codex and then Claude Opus 4.6.
It was a wild morning. My phone was just useless. But the reason this is so important isn't just the timing,
No, it's not the marketing stunt. It's that this moment completely scrambled the way we think about AI.
And that's really our mission today. We're not just going to list off benchmarks and specs. We're here to unpack this huge split, this bifurcation that just happened in the market.
Exactly. For years, it was always Model A is better than Model B.
Yep.
A straight line.
A simple race to the top.
Right. But that race is kind of over. Now we're looking at two completely different philosophies for how an AI should even work.
Two different tools for two different jobs. You wouldn't use a hammer for a screw.
Precisely. You have the speedster, that's OpenAI's Codex. And then you have the architect Anthropic's Opus. And if you try to use one for the other's job, you're going to fail.
Understanding that difference is everything.
It's the key to thriving in this new landscape.
Okay, let's start with the speedster then. The GPT-5.3-Codex. I was reading through the technical report, and honestly, there was one detail that just sounded like pure science fiction.
I think I know what you're talking about, the recursive origin.
Yes. The idea that this model, GPT-5.3-Codex, actually played a role in its own creation. It helped build itself.
It's a pretty mind-blowing disclosure. OpenAI revealed that the early sort of alpha versions of Codex were used to debug the training protocols for the final model.
Okay, hold on. We're not talking about it writing some simple script here.
No, not at all. The model was analyzing the actual training pipeline, the code used to teach the AI, and it found logical flaws that the human engineers had missed.
That's the phrase that gives me a little chill. Flaws humans missed. We always talk about the singularity, right? Is this it?
It's a step, a measurable one for sure. But what it really means, practically, is that the model feels different now. It isn't just generating text anymore. It feels more like a computer operator.
Right, which brings us to steerability, because I've been there. You ask an AI for a script, you see it going off the rails immediately, and you're just shouting at the screen.
The shouting at the void experience. It's so inefficient.
Yeah.
OpenAI fixed that.
Yeah.
With 5.3 Codex, you can see its thinking traces in real time.
It shows its work.
It shows its work.
Yeah.
And if you see it making a mistake like importing the wrong library, you can interrupt it, correct it, and it just pivots instantly. It doesn't lose context.
So it's more like pair programming.
Perfect analogy. But that only works because of the speed. And the speed isn't just software, it's hardware. That's Spark.
GPT 5.3 Codex Spark. This is where the hardware nerds, myself included, kind of lost our minds. OpenAI partnered with Cerebras.
The wafer scale engine 3. The WSE3. This is a fundamental shift.
Okay, so for anyone who isn't reading semiconductor journals, why does wafer scale matter so much?
Well, think of a normal computer. You have lots of tiny chips cut from a big silicon wafer, like a pizza. You connect them with wires.
And signals have to travel between them. There's latency.
Right. It's a traffic jam. Cerebras just said, forget cutting the pizza. They use the entire wafer as one giant chip.
So no traffic jams.
Exactly. It almost completely eliminates the memory bottleneck. And that's how Spark can generate over 1,000 tokens per second.
1,000 tokens a second? That's, what, a few pages of text in the blink of an eye?
It's about 15 times faster than what we were used to. It's literally faster than you can think. The answer is just there.
But there has to be a trade-off. You don't get that speed for free.
And there is one. Memory. The WSE3 has about 44 gigabytes of on-chip memory. For an AI model, that's actually pretty tight.
So Spark is lean.
Very. It's text only, no images, and a smaller context window, 128K tokens.
So you wouldn't use it to analyze a giant code base?
No. Spark is for the loop, quick fixes, rapid iterations, debugging. It's a sprinter, not a marathon runner.
Okay, so that's the speedster. Now let's talk about the other side of the collision. The architect. Claude Opus 4.6.
Yeah, Anthropic went in the complete opposite direction. While OpenAI chased speed, Anthropic doubled down on depth, on reasoning, and massive context.
And when you say massive, you're talking about a number that's hard to even process.
A 1 million token context window. In beta, but still.
What does a million tokens even look like in the real world?
You could feed it an entire multi-repository code base. You could upload the documentation for a whole new programming language, a few novels, and you'd still have room to spare.
Here's my skepticism, though. Just because the model has the information doesn't mean it can find it, right? It's the context rot problem.
It is. Historically, models just forget things in a long conversation.
Right.
But look at the data on this. There's a benchmark called needle in a haystack.
Right. You hide a fact and ask the AI to find it.
The previous model, Sonnet 4.5, scored about 18.5%. Basically guessing.
And Opus 4.6.
76%.
Wow. Okay, so that's not an incremental update. That's a different class of tool.
It really is. It can hold the entire architecture of a system in its head. And they added this feature they call adaptive thinking.
Where it decides how hard to think.
Exactly. You have 4 levels: low, medium, high, and max. Max triggers this deep chain of thought process. It stops, it plans, it critiques its own work.
For when you absolutely need it to be right.
For high-stakes engineering, yeah. And low is for when you just need a quick email. It optimizes for cost and latency.
So Speedster versus Architect, let's see how they actually stack up in the real world. Because the benchmark results were, well, they were surprising.
They were. And they support this whole split market idea. GPT-5.3-Codex is just superior for terminal interaction.
The hands, bash scripts, git commands, that kind of thing.
Exactly. But Claude Opus 4.6 is better at agency and computer use. Navigating an OS, multi-step workflows. It's the brain.
But I want to talk about the SWE-AGI benchmark. That's the really tough engineering test. You would assume the architect would win on the hard tasks, right?
That's the logical assumption. But the data says, nope. On the hard tier of tasks, GPT-5.3-Codex actually beat Opus 4.6.
Really? The Speedster won the hard stuff.
It solved 5 out of 8 hard tasks. Claude only got 4.
So what happened?
Well, it's not that Claude is dumber. It's actually the opposite. The report says it spends more time reading and planning.
Analysis paralysis?
A little bit. In that specific test, Codex's approach of just trying things, failing, fixing, and trying again was actually faster at finding a solution.
So Codex is the engineer who just types furiously and breaks things until it works. Claude is the one staring at a whiteboard for 3 hours.
And sometimes you need that whiteboard. On the Awesome World benchmark, where it has to navigate a computer interface like a human, Claude wins easily. 72.7% to 64.7%.
Okay, so they fail differently too. We have to talk about the hallucination.
Yes, this is so important. GPT 5.3 Codex rarely makes a syntax error. The code it writes will almost always run, but it suffers from logic hallucinations.
Meaning the code runs, but it doesn't do what you wanted it to do.
Exactly. It gives no errors, but it's just wrong, which is dangerous because you trust it. Claude, on the other hand, is much better at catching its own logical mistakes. It will stop and say, wait, this is a bad idea.
Yeah.
But it can be verbose. You could overthink things.
Like that Swiftagon fight test on Reddit.
Perfect example. Someone gave him both a really hard concurrency problem in Swift.
And
Claude basically refused to write the code.
yeah.
It acted like a senior safety inspector and wrote this huge essay on why the entire approach was dangerous and prone to threatening risks.
And
Codex just wrote the code. It was a tight, fast solution to the immediate problem. It missed the deeper architectural risk, but it worked.
It's the difference between a safety inspector and a mechanic who just needs to get the car running.
And sometimes you just need the car to run.
Speaking of risks, let's get into the scary stuff. We're giving these things terminal access. What about security?
It's a huge focus for OpenAI. GPT 5.3 Codex is the first model to hit high capability in cybersecurity under their framework.
High capability for an autonomous agent sounds slightly terrifying.
It's a double-edged sword. It can automate end-to-end cyber operations. It performs at a professional human level in capture the flag hacking contests.
So it can hack.
It can hack and it can defend, which is why they launched that Trusted Access for Cyber program. They're trying to arm the defenders.
My concern is simpler, though. Can it accidentally delete my hard drive? Can it just arm my life?
It's a real risk. You tell it to clean up a folder and it cleans it up a little too well. So OpenAI specifically trained it against data destructive actions. Things like rarm-rf or git reset hard.
How did it score?
It scored a 0.88 on avoidance.
Wait, 0.88, that's That's not 1.0.
No, it is not. It's a huge improvement,
Yeah.
but it means there's still a 12% chance it could get confused by a vague prompt and do something you really regret.
Maybe don't give it root access just yet.
Or rely on the sandbox. It runs in an isolated container, so if it does try to wipe the drive, it's a virtual one, not your actual machine.
Okay, that helps. Let's talk about the money, though. The pricing on these things is getting complicated.
The pricing reflects the philosophies. Claude is premium. You're looking at 15 to 25 per $1 million output tokens.
Ouch.
Yeah, it's priced like a senior engineer.
Okay.
You're paying for the deep thinking.
And OpenAI?
It's a complex tiered system, plus pro business. But here's a tip for listeners. Look at aggregators.
Aggregators.
Services like Global GPT, they buy bulk API access. You can get Opus 4.6 through them for something like $5.80 a month.
Wait, from $25 million to under $6 a month.
Yeah, it's democratizing access to the smartest AI brain on the market.
That's a huge tip. So what does the new workflow look like then? We're not just typing in a chat box anymore?
No, if you're doing that, you're living in 2024. The best developers are using what's called tiered logic.
Tiered logic. Explain that.
You use the brain Claude Opus for the planning phase. You give it the specs, ask it to design the architecture, find the edge cases. It draws the blueprints.
Okay, and then?
Then you hand those blueprints to Codex.
Yeah.
You say, implement this function, iterate on it until it passes these tests. You let the speedster do the heavy lifting.
So you're not the coder anymore, you're the manager of an AI team.
You are the conductor. And Anthropic is leaning into this. They've integrated Claude into Excel and PowerPoint. It can generate actual .docs and .ppdx files now.
That is a massive shift from write this code to make the presentation for tomorrow's meeting.
It's the shift from coding to orchestrating. Your value is no longer knowing syntax. It's knowing how to manage these powerful agents, which one to use for speed and which one for depth.
Which kind of brings us full circle. If GPT 5.3 helped build itself, and Opus 4.6 can manage its own teams,
you see the recursive loop, which leads to the big provocative thought. At what point does the human in the loop just become the bottleneck?
if the speedster is working faster than I can think and the architect is remembering more than I ever could,
We physically can't keep up. We become the slowest part of the system.
something to think about. Are you the conductor or are you just slowing down the orchestra?
A humbling thought.
Thanks for listening. Follow Tech Life Well podcast channel for more helpful episodes.